Okay, so with this section, we are looking at a special type of log. It's called the natural log. It is log base e, so the exponential function of x. And the way we actually write it, so we don't leave it as log base e because it would just be a lot of letters there. We call it the natural log. So we say ln of x. That's the natural log. So we're going to be using this guy today. But I want to tell you that it's just log base e. Some things to highlight about the natural log is that the ln, right? Natural log of 1 is equal to 0. When we take the natural log of e to a power, those two will cancel and you'll just get x. So that we're going to use this with our equation. So if you have log base e, which is ln, natural log, and you have an e there, they'll cancel out. Same thing if you take the exponential function e to the ln x power, those two will cancel, the e and the ln, and you'll just be left with x. We're going to use that again. So here we go. With just writing these as a single log, since it is a log, we're going to use our same log rules. So what we're doing is trying to write it as single log when subtraction means division, and we just have to make sure that we deal with this 2 first. So it'll be the ln of 15 squared minus ln of 75, because we got to move that coefficient. And so that's the ln of 225, which is 15 squared, over 75, because the minus sign means we divide when we write it as single log. So we'll get ln of 3. So it's a lot of the same manipulating that we did before. So again, here, we're moving that guy. So it's the ln of 7 plus the ln of 5 squared. You can write parentheses. You don't have to write parentheses. And since there's a plus in between, that means we're going to multiply 7 and 25. So we are taking the ln of 175. Again, same log rules. Make sure that those coefficients are things that we move right away. This guy's important because, again, we've got coefficients. And now we have 2 terms here. So what we're going to do is we're going to write ln x cubed and minus, now it's the ln of 2x, that whole thing squared, not just the 2, not just the x. So we will combine these by writing it as ln, and the minus sign means I'm going to have a division sign here. So ln of x cubed over, and then it's 2x squared. What is 2x squared? It's actually 4x squared, because both of those are being squared. And then we'll cancel our x's because it looks like we can do that here. So I've got 1x in the numerator, right? I'm going to cancel. And I've got a 4 in the denominator. And that's my final answer. And this last one's kind of nice. You're just moving everything before you put it all together. So it's ln x cubed plus ln y squared plus ln of 5, which means when I put it all together, it's the ln of 5x cubed y squared. Okay, so that's our log rules applied to our natural log, which makes sense. It's a log as well. And these last 2 are solving. So solving natural log equations, we need to condense first. So if we have more than one log, we got to make sure to write it as a single log first. And then we're going to use our inverse of our natural log, which is the exponential function. We're going to take the e of both sides, because that's going to undo. That's the opposite. So we're going to use that to cancel ln. So ln is by itself. I've got a single natural log here. So I take the e of both sides. And what that means is now I'm going to make the ln of x the exponent for the exponential function e. And I have to do the same thing on the other side. It becomes e squared. Taking the e just means making both of your sides of your equation the exponent for your e here. And we do that because e to the ln of x, those will cancel and you're just left with x. E squared doesn't cancel, and that's just your final answer. So the idea is after the single, you've made your single natural log, you take the e of both sides. For this one, it's not a single natural log, so we got to put it together. Ln 2x, ln of 3. The plus means I'm multiplying them, so it's actually ln of 6x here equals 2. Got a single log. I'm going to take the e of both sides. What that means is it's now an exponent, which means it'll cancel here. And I'll get 6x is equal to e to the second power didn't cancel, so it's e to the second power here. X was by itself for our first one. X is not by itself for this guy, so I have to keep going. I divide by 6, right? Because 6 times x, divide by 6, so I can cancel. And I get x is equal to e squared over 6. And we'll just plug that into our calculator as well.